All right, there we go. So, hello, Merve. How are you today?
I'm fine. Thanks a lot for having me. How are you?
I'm great. Great to have you here. Thank you very much for joining. And today we're going to be talking about a bunch of stuff. Most importantly, first of all, vision. We're also going to be talking a little bit about Hugging Face and about the future of AI and what it has for us. Sounds good?
Sounds good. Let's go.
Perfect. Okay, so what is so exciting about vision these days?
I think vision these days, like if you asked me this question last year, I could have had way more things, but I really feel like these days vision is a little bit more solved than ever.
Right?
Like the amount of problems that we have solved last year is much more. And these days I feel like we are just optimizing, plus minus 1 points on benchmarks. Yeah,
It is
it's
interesting.
not as exciting, I would say, as last year, but it's okay.
Well, it's interesting that you say that because I mean you're at the forefront of the whole thing, right? But like for regular humans like us, it hasn't really touched us, has it? Like what is in there in the labs that is already solved, but that has not reached, like regular consumers?
I honestly feel like it's not the regular humans per se, but not even the developers, in the sense that people just don't know what they can do with the vision models. At least most of the task-specific vision models, because like VLMs are everywhere. Like for instance, in your phone, like everybody is sending cloud or whatever some documents or like images and playing with it, and um it's a bit going to the end user, but I have a feeling that people just aren't really knowing of what they can accomplish with specific ones, like object detectors, image segmentation models, you name it, like video models, video tracking, object tracking models in videos and stuff.
Okay, I hear you. Now, would you mind giving us kind of a brief overview of all of these things that have been solved already? Because you're like, yeah, it's solved, but I'm like, what exactly has been solved though?
Um, I think it all happened very fast, especially recently. Like, I remember when I was first following Vision, and I think basically it all started with the Vision transformers. Like, before that, we were working with convolutional neural networks and stuff. With Vision transformers, I felt like they are more scalable, and also, it's the fact that you can do a lot of transfer learning with them. So, like with Vision transformers, the Vision had its own birth moment,
Right.
and then we were able to transfer like many tasks, and people started combining different architectures and just adapting Vision transformers to many different tasks. So, object detection, image segmentation, image classification, especially were they had a huge leap, especially for the labs that were training things. And then I think Vision had its own GPT moment with LLaVA. So LLaVA, if you don't know, is an architecture which was, so before LLaVA, there were many other models like LLaVA. LLaVA is the model that can take in an image and text prompt and output text. And it's like LLM, but that can input images, basically. We had many models before, like Flamingo, I don't know, like you name it, but they were mostly closed. And then there was, for instance, IDEFICS by Hugging Face and stuff, but LLaVA was like very, very scalable. IDEFICS, the first IDEFICS, for instance, was first open implementation of Flamingo, and then LLaVA came, but LLaVA is like way more scalable and more easy to train, because basically, like, to train a LLaVA, sorry, I think I went a bit low level, but bear with me. So you just take like a image encoder that from a model like Clip, and LLM, and then just train a projection layer in between. So basically like trying to connect the image to text in a way, and then do another round of training. So it's a bit like, I don't know, like how you would pre-train an LLM and then do instruction fine-tuning, but with image and text pairs when you think about it. And everybody started training LLaVA. And from there, people started doing a lot of LLaVA improvements, like improvements on LLaVA architectures, adapting it to video, feeding multiple frames, or like interleaving image and text, like you can say, okay, you see this image, and then you insert the image inside, and then you see another image, blah, blah. Like this is called interleaving an image and text and stuff. And then it all came to the moment of the point where like we are a bit saturated at the moment, in the sense that we don't really do a lot of architectural improvements anymore. Like people are oftentimes like, we came to QN models by Alibaba, which are very capable models. These days, everybody is just training, like continuously training QN models or building stuff on QN models. So like, we don't really have any architectural improvements anymore, or because like also many of the labs are releasing models in like different sizes, like 1B to, I don't know, super big mixture of experts models. It's just I feel like I am not as excited to read research papers. Maybe like one thing that is exciting, let's say, is we have more alignment techniques like reinforcement learning from human feedback, and like all of that stuff coming up for multimodal things. Those papers are more exciting, I should admit. But yeah, like overall, we have reached a point in vision where like we are just improving. Like we have established benchmarks, just like LLMs, and we are trying to improve, the document understanding, video understanding, agentic vision reasoning. And, like there was this recent Kimi model that was able to look at the web, few images and generate like website or brand or whatever.
Yeah, that was
like even just write the website code looking at the few like images.
It's an open model available in different providers, by the way.
Yeah, correct. So yeah, like I think vision just evolved to a point where many things are just tied to VLMs now,
Right.
and there's not a lot of big labs doing vanilla vision anymore. And when I refer to vanilla vision, I refer to everything but vision language models, basically.
Okay.
This also includes some of the models like Segment Anything model by Meta, like the latest one especially. Even though it can take in text prompt, it's not established vision language model. Like it cannot take long prompts and like do instruction work and stuff. Sorry, I kind of yap a lot.
That's great.
I think I could yap for.
You're actually giving us a master class evaluation right now.
So basically, like to sum up, we used to have CNNs, and then we had vision transformers. Like it was a birth moment for image understanding tasks like segmentation, detection, image classification, and then we had the GPT moment with LLaVA. And then now we are a bit more saturated in large models and large pre-training, doing everything.
It's crazy. This is a super interesting masterclass. Thank you. Like, so basically, we started off with CNNs. How long did we get stuck with CNNs? Like that lasted for a while, right?
For a long time, I think. I cannot name. I think it was until 2019. Like VIT paper, I'm not super sure. I think it was until 2019 that we had it for a long time.
Yeah, and then since then we got LLaVA, and
Yeah.
then we got all the Qwen models, and now we're basically just fine-tuning those models for our use cases. That's crazy. Awesome. Awesome. And are about this vision transformers, like all of vision now is going to be about transformers, right? Or are there any applications of those older architectures that are still there, but are they still useful or not anymore?
I mean, there is some models that combine too, like ConvNext. They are a bit old. I am not very, very sure, like, because basically, like, I haven't been reading latest papers anymore. Like, I used to read a lot more, but like, since the VLMs came, like, it's been very much VLM everything. There was like works, for instance, that were using CNN based image encoders for vision language modeling and stuff, or like there has been so many clip-like models. Like if you don't know clip, it's like a model that combines an image encoder and text encoder and just tries to sort of match the image to text. So like you connect both modalities. There has been like clip-like models that still use CNN based architectures for the image part. There is probably a lot of still models, like vanilla models, like object detectors or segmentation models that use CNN based architectures. They're still in use because it's like it's simple, it's fast, it does the job, you know.
And what kind of jobs though for what kind of jobs do you think are better for CNNs than, or that we use CNNs on top of those jobs other than vision transformers?
Honestly, like to be frank, I think vision transformers are kind of better suited for anything that. So basically, like vision transformers, there was a long blog post from Lucas Bayer, the GOAT, about how vision transformers are like just too superior for every single thing. Like, because there was a claim by Jan LeCun, and he was saying that everybody's still using CNNs, and like vision transformers are not scalable. It's worse by means of efficiency and stuff. But Lucas just how do you say, like, invalidated those claims. So like at this point I just I don't know, like it's I would say if I were to just if I had a ton of data myself that was labeled, and if I were to just train a model, I would just slap a CNN. VITs are much better because, like, in the sense that they have more, you can do more transfer learning with them, in my opinion. And yeah, like I don't think we're like it really depends, I guess. If you want something to do the job and just train, do like a lot of training, if you can afford a lot of training, you can use CNNs, but like you can also use like CNN based image pre-trained image models to like still you can also fine-tune these. It's okay, like you can put a head on them, but VITs are much better suited for transfer learning.
I hear that. Okay, interesting. And you talked about Jan LeCun. Have you had the chance to meet him?
Yeah.
Yeah. How is he? I haven't actually met him ever.
I met him once in a dinner at Station F,
Right.
and I wanted to kind of like approach to him and ask to do a bit more releases on HF, and I kind of felt embarrassed after that because like he wasn't the right person to do that. He's a bit like a research vision director in the sense that I think he determines the strategy for the research team, and yeah, like it was a bit embarrassing, but we have a photo together, so
That's cool. That's pretty cool.
but the rest of it, he's like a very fun person. He cracks jokes, you know, like he's very chill to talk to. Like I actually wanted to talk about him a bit today because like I wanted to make some predictions for this year. And like I think his new company is like working on world models and stuff with V-JEPA. And I think this will be like huge this year. So
Can you talk more about that? Like, what does that even mean? World models.
let's get to it later.
Okay, we can talk about it later.
Because like I feel like I have a very like a jumpy brain. Like if I can, like it just jumps from one topic to another, and it will be very hard to follow. And this podcast will take like 3 hours if we just do that.
Talking precisely about like future things that are coming, I was precisely going to talk to you about to ask you about what is coming and what you think that these vision models are going to be used for in the coming months or in the coming years. So let's start with that. How are the current vision models that we have going to impact regular people?
Regular people, I actually never thought about this because like I think at HF we are very biased towards building for developers and stuff, because HF is, HF ecosystem compared to other AI companies a bit more lower level, and like it involves training and stuff. So I mostly think about the developers.
How is it going to impact developers then?
To be frank, I think like are you precisely asking my predictions?
Your predictions. What would be your predictions?
Okay. This year, I'm super bullish on a few things that are a bit intertwined, and they're a bit like the theme is like generalization of vision to world and taking actions. So, in my opinion, this year there's something called world models, and world models are a bit like compression of the world. Like that's what also Jan LeCun says a bit. He says that you cannot really learn world through text tokens. And for instance, you can see this trend with Genie 3 by DeepMind. Like if you have seen it, it's like a 3D model where it takes in the action input and the current scene, and then it outputs like the continuation of the 3D world that you are in. So it's like a 3D world. There's also this company of World Labs by Fei Li. You probably have heard about it. She's also trying to solve a similar problem. And Jan LeCun, I think his new lab is also doing a similar thing. So basically what they are trying to do is that they want to compress the world, and they want models to model the world itself in a spatial way. I don't know how to pronounce it, like spatial way. Like awareness of the surroundings and stuff. And this unlocks a lot of things. I think first and foremost, it's like one of my favorite parts of AI is I really want AI to do very boring things and things out there in the world, and not creative things, let's say. It's a bit of a weird take, but for instance, if you want autonomous driving, if you want robotics to be more out in the world, you need to be able to compress noisy environments, right? And prior to the machine learning taking over this, we had like physics simulators and stuff, but they are too isolated. So world models in a way enable to compress the world, and like because you have a ton of like images, 3D models, 3D data, etc., to be able to compress the all of the observations. Like these are called observations, like the state that you are in, to be able to take an action. It's called observations. Right. So this can include like sensor data. I don't know, like mostly images, by the way. Like these people are using images these days. Images and stuff, you actually need to be able to model the world in a very good way. And I am very bullish in that for this year, seeing the Google DeepMind's work, Fei Li's company, and Jan LeCun's company as well. For instance, like last year, they released V-JEPA 2, I think. It was also like model that does this through videos. NVIDIA does a similar thing. They have a platform called Cosmos, I think, and models to like world models as well to do this. So I'm very like bullish. At HF, we also have like we do something similar. It's called, it's not world model per se, but it's like vision language action model, and it's like rather than taking an action like when you, for instance, like think of your computer keyboards like going up and down and stuff. These vision language action models are actually taking actions from like natural language. And like for instance, think like Richie Mini and like seeing something and you talk to it through natural language, ask it to do something and then it takes an action. So yeah, like these are also like extensions of vision language models, by the way. It's just the difference is that they take actions. Last year, for one of the first implementations of this, I remember a lab reached out to us. They were using a vision language model called like very early ones called PaliGemma. PaliGemma was previously released by Google Brain when it was Google Brain and not Google DeepMind. And it was basically like PaliGemma but extended for action. So actually like vision language models also extend to robotics and stuff. So like I was very much looking forward to it. And like when you think of action as well, it's also a bit like it goes into agency and stuff. So like once you enable very large generalization into vision, language, or like world, you can have a lot of possibilities that we don't know. Like we were predicting last year that these things would happen, and they actually happened.
Very fast, actually.
Yeah, it all happened very fast. So yeah, like overall, I'm very bullish in those. And second thing I'm very bullish about is like actually like very agentic like reasoning models going on phones and interacting with the apps and stuff. So this I wanted to, if we were to take this video by December or something, it would have made more sense. I already had this prediction from last year, actually, from another podcast with a friend of mine. But we have it very mainstream with OpenClaw and stuff at this moment. I also predicted that we would have models that operate over screenshots on phone. Like it looks at the screenshot and it decides where to click and things. And last year there was like an 8P model that was released like that from a Chinese app. I think it was Mini CPM, but I'm not very sure. So, but it was obviously like sending a request to server because it's very hard to run an 8P model on your phone reliably. I would say this year I would expect these models to be going like local, or like we could have also like, so we can have models being smaller, but also we could have some hardware leaps perhaps, like we could have some phones with a bit more like AI oriented accelerators inside. So I would say I would like the models to not only go local on our computers, but also on phones or like tablets and stuff. So yeah, like these are, I think, my predictions for this year.
That's super interesting. We have, so basically the world models, this more complete assistance like OpenClaw, and local models. I wanted to go a little bit further with world models, or just pick your brain about this, because we currently already have this vision models that can make predictions and take action on top of those. Like, for example, what we have with self-driving cars and stuff like that. How would world models improve those behaviors, or are they going to be used with something completely different?
To be frank, we don't really have visibility into what labs are doing right now, but we have different types of world models. So when I refer to a world model, I'm not referring to a single thing. It's like there is many types of them. There is like even like there is diffusion based ones and stuff. Like even the outputs and inputs of what each lab is doing is very different. Some of them are into like, I think, so as I said, like the one that was by Google DeepMind was directly predicting the next 3D environment in a way, because it's more like an immersive experience.
And when we put that together with robots, that's going to be crazy, right?
Yeah, like you can even do, like, for instance, like with such model, for instance, I would say you can generate more data, which is what NVIDIA is doing, I think, like generate more data to train robots, for instance, when you think about it, because like as far as I know, NVIDIA has released some data sets and stuff around it. We need to link to them. They are on Hugging Face. All of them are on Hugging Face.
There you go. Absolutely, for sure.
Yeah.
And about OpenClaw as well. That's something that went super viral recently. What do you think is the future of this kind of systems like OpenClaw?
To be honest, like I think I would. So I haven't tried OpenClaw myself because I found it like to be a bit insecure. Instead, I tried something called IMCP that was on Mac. It's very nice and it supports like Hugging Face and ecosystem in general, like inference providers and local models and stuff. And I tried it with some Jeanne model, I think, locally. Because I wanted everything to stay local. Like I don't want any security breaches, or I don't want my data to go. Because like you're giving very personal information to these models, you know. I would say I expect them to be more secure and stay completely on device. Like reason why I'm using Apple is because like I just know that things stay here and not go to places. I would say I expect especially with the agentic models getting smaller and smaller, like hopefully we will have long context models that are 1B and stuff, that are super capable to
Run them in our
so like
phones.
like that. I would like them to go on the phones and stay there, and just not waste a lot of tokens and just giving us a huge cloud bill. I would say I see them just going on device completely.
Right. And what do you think is an overrated or also an underrated direction currently in research related to vision or in AI in general?
Let me think. I would say not research direction per se, because I used to think that in general, like vision language action models are very underrated, and currently they are appropriately rated. But I would love it if like more developers would use vanilla vision models to do things. Everybody is trying to solve vision language, like use vision language models to do stuff like object detection, for instance, but they are like super overkill. On the other hand, you have much smaller models that you can train, and like part of my job is to just try to reduce the barrier of entry to train these models. I dedicated last year to build like a lot of training scripts, documentation and stuff around object detection, image segmentation, etc. Or I would love it if they could actually like take smaller vision language models and fine tune them on object detection or something. Everybody's trying to use like very large models to do very general things, but instead, like, I would love it if people could just how would you say be a bit more brave and not be as intimidated, because it's really not that hard. I call it ever since like since I was super young, I call it cutting a bread with a katana, and not not a knife. People are still doing that. I find many of the vision models to be super underrated, nevertheless. Yeah, this is an underrated thing. And an overrated thing, I would like to say coding models. Like, I like coding models, I use them, but I think there is much more to AI than coding models in general. Yeah.
Yeah, it is crazy. I mean, that's a hot take actually. I love coding model.
Yeah, I
As-
do love
yeah.
coding models. I don't have any I use them. I was talking to Alejandro and others the other day. I do like a bit like FOMO driven vibe coding. And and this is like I want to keep coding, but model does what I do much faster. And all of my colleagues are like vibe coding, like not vibe coding per se, but are using coding models to do things, and they do it very fast.
Yeah, I can't remember the last time, but I actually wrote an entire function without any coding model. It was crazy.
I mean, I did basically like last 2 days ago. I had some time, so I was like, okay, for a hobby, I will just write some code, and I did that, and yeah, I just want to use my brain. Also for coding because I find coding to be fun,
It
but
is.
like it's a bit FOMO driven. Like I don't want to stay behind in a way, so I use coding models to do things.
Completely understand that. Related to vision again, since you're the expert, do you have any recommendations for beginners who would like to get started in vision?
I would say it. I would say you should try to first find a problem to solve and be curious about it. Like first maybe try to solve the problem with a vision language model, and then just try to understand the shortcomings of it and try to improve it by for instance, like if you have like a problem where you are trying to solve object detection or something, you can just initially play with it using vision language models. They will output bounding boxes as tokens and you will see that. And then you can understand a bit, like how it works and stuff. And then actually train a object detector. Like just go to Hugging Face, okay? And on the when you go to models, you can just put them over there. Right?
Yeah.
I'm an absolute dumb. Just go to Hugging Face, okay? And then on the left hand side there is in the models page, left hand side there is like task filters. You will see object detection. Or you can go to Transformers documentation. Go there. In resources, there is task guides. You will see object detection over there. Just run that task guide. That's very standardized. You can plug and play any Transformers-based object detection model with it. Just run that and see what it does, and adapt it to your problem. It's very easy. It's like really easier than how you think it is. And then you can just start to iterate, try different Transformers-based object detection models. You can filter for them, or for instance, in Transformers, I think there should be I will curate a list of Transformers models that object detection models implemented in Transformers library, and give link in this video. Like you can just plug and play different models and just experiment, what worked, what didn't work, etc. Just play around different augmentation methods, different I don't know, just experiment. They are super small. They are I don't know, 50 million parameters. You can play with them in Colab free tier. You absolutely have zero excuse these days to not do that. So yeah, I would say be curious and just try to solve a problem, and then it will fall off. I'm serious about it.
Now everybody can start, and I would encourage software engineers as well to get started with this. Just be curious. There's a lot to learn, and it's very, very fun. Talking about Hugging Face as well. You've been part of Hugging Face for a while, haven't you?
Yeah, it's
gonna be 5 years. So
Awesome. How do you like it?
I love it. I don't know. I feel like I'm at this point I'm way too opinionated about it in the sense that like each AI company have their different culture and way of operating, and I'm very biased towards how Hugging Face operates. I'm very used to it. And I genuinely like people, and I genuinely like the ethos of like Hugging Face as well. Like I I don't see myself like much elsewhere.
What do you like especially about it?
I think first and foremost, I think it has a lot to do with open source, right? I really like open source. It really empowers people, in my opinion. If the AI was in the hands of like the few, like you don't get a say in like how it's used, but like if you have the open source AI, you can just build anything. And I think or like we would have to live according to principles of few companies and like how they want to filter their AI or like build their AI. What with Hugging Face, you like with open source models, you do have the freedom to build whatever you want. So I genuinely believe in open source in general, and like if I were to work in somewhere else, I would probably it would still be about open source. I like Hugging Face because it's not biased, like it's not biased towards a country's models. It's not. It tries to empower everyone. It has been very generous towards developers by means of storage, for instance. Some people were asking how we make money and stuff, and like this has been a recurring question, like how we burn the storage. Yeah, like I really like what the company serves to, and like I think with our generation of people, it actually matters a lot that you align with your company. Other than that, HF, like people in HF are super friendly, immensely helpful, like non-political in the sense that like they are not transactional. Like you can just ask anyone for help. Like Alejandro asked me, "Can we make a video?" I said yes. And or like you can ask questions. Like you will see the most goated developers telling you, you know, like there is no stupid questions. You can ask me anything.
Absolutely.
I really like it. I really like that it cares about the well-being. It acknowledges that there is more important things in life. Like you can, I don't know, the working conditions here are very good compared to many like very like hustle culture companies. I really like it overall. I'm happy that they built this company so I can work for it.
That sounds actually very, very important. The open side, is especially now that AI inference in particular is becoming, or is probably going to become, common commodity, maybe at the same importance as electricity in some years, right? Do you see that happening?
I'm not super opinionated about it, I guess. Like I have no strong opinions on this. Probably yes. I genuinely see the energy company stocks going up, but yeah.
Let's talk a little bit also about like the origins of HF. So you were here in the early days of Hugging Face, or earlier days.
Earlier.
How did Hugging Face become so central in the open source ecosystem?
I think like we have many people that determine the company's strategy in the sense that we are very flexible and we try to assess the ecosystem well, and we act according to it. I think machine learning paradigm has changed a lot, like in the last I've been here 4.5 years, I think. When I joined, it was all NLP, BERT, and stuff,
Yeah.
you know, and then it was, and then the stable diffusion and, all of the autoregressive models came and like everybody was sharing their LoRa's and stuff like that, like we attracted so many developers. During the time, like it's important that you have the labs sharing things, because those labs sharing things actually matter a lot. People can build on them. For instance, like when you think about stable diffusion, like very early, now it's flux and stuff. So I think it's about building good relationships with, initially at least, with the research labs, both in university labs. Like especially, it's a bit funny. I remember the time like when we were trying to reach out to researchers and stuff in order to put their recent models and the weights and the code and stuff on Hugging Face, or like integrated transformers and diffusers. So I feel like the starting point with Hugging Face, with initially transformers, was played a huge role in standardizing the model definitions, and then we had diffusers coming in. When you have like how do you say, like pre-trained models in like singular, they defined in a singular way, you enable standardization. If you enable standardization, people will be using your library a lot. And we saw this, like it was the most used machine learning library. And because of this, researchers, we attracted a lot of pre-trained models on Hub, and then people came, trained their LoRa's and stuff, or further fine-tuned things and shared. And then Spaces, like I remember the time when we launched Spaces. It's a bit crazy now that I'm looking back into it. So initially, that one mattered a lot, and then establishing good relationships with other companies, because these days it's the company labs that are making huge noise.
Yep.
Unfortunately, I would much rather have everyone, like universities getting fundings and stuff, doing like, more. But yeah, like having big companies on HF sharing things and stuff like that actually changed a lot. And yeah, like once you have the place to share things, and it also matters a lot for science, because when you have the weights, and if they're like standardized, or like the code is in the open, you can reproduce things. So it also enables open reproducible science in a way. And because of this, I think it's kind of furthered research as well. Like a great example is we had like Google Brain back in the day sharing PaliGemma. And then after PaliGemma was done, I think it was another lab. They built something called ColPali, which is like a retriever version of PaliGemma. Let's summarize it like this. And then after ColPali, there was ColQwen. And then other libraries started building these models like these. The latest ColPali-like model was released by NVIDIA. It was a bit of a different architecture. But yeah, like you also enable a lot of like research directions, and like open science actually adds up a lot. And I'm pretty much sure like it contributed into a lot of the closed models. Like I swear, like closed labs have used a lot of open science and open source work to train their models. So I think it matters a lot that you give the people the means to share things. Sorry, my brain is a bit messy, and like for me, it's like I kind of like to jump from topic to.
No, it's great.
At times, yeah.
No, I mean it is. It's all about how open source is important right here.
Yeah. It's a bit of a central theme here.
Yeah, I'm interested. Like what you mentioned. Are there any interesting stories about when you launched Spaces?
One thing that was like, I don't know if it was first time I joined Hugging Face or after I joined Hugging Face, but like me and my friend, so he's like a hacker in Turkey and like he was working at HackerOne, and we did like a live stream to raise money for like we used to have a lot of forest fires in Turkey. That was like, it's not a funny story, but it's nice. Like there was a lot of animals that needed saving. There were people who had, lost their homes, like although few, um, and some forests and stuff. So like we did like a fundraise. It was after I joined Hugging Face because we launched Spaces by then. Sorry. We were like showing like very interesting applications of AI, and to keep people interested and get more money for the donations. And after I vaguely remember there was a model called vector quantized GAN combined with clip, and it was like basically like this. You would type something like avocado shaped chair, the DALI examples, and it would show you, and like it would do like a latent walk, and then you would see the intermediate outputs and stuff. And it was like such a big thing back then, like now you see the image generation models, it's crazy, but like back then it was huge.
Yeah, it was the first time ever.
It was insane. Like I remember that, for instance. So like there was this music model. I don't remember much, but there was this music generation model. There was like few demos by Google and stuff. I wish they had put them on Spaces back then, but at least we get demos by them now, better late than never. Yeah, like I really remember it. And then I'm like, my friend shared that other day, like a video of me, I can send to you, like talking about vector quantized, and like I was like, wow. We have come so far. It's insane,
Yeah, it is crazy, and in so little time, such a short time. Yeah, and just for those who don't know, just for reference, Spaces are just a great way to share, of course, your machine learning applications, but pretty much any application actually. Now you can deploy your MCP servers there. You can deploy any application as long as it fits into a Docker container. Amazing, great. Yeah, the other day you were also telling me something really fun about precisely the origins of Hugging Face, which is how people used to share their models before. I find that crazy. Like, I cannot imagine a world in which people share their models in a different way. Like, how did people used to share their models?
We had a lot of research labs, and we still do, by the way. It's just way less. And it's partially due to like a lot of work that has been put out there from both AK, the Twitter icon, AK, and Nils. We had people, especially research labs, sharing in Drive, like Google Drive links. There is people who share, like, at least I think I've seen people sharing on Dropbox.
Yeah, sure.
Or like, it's a bit crazy. Like they redirect to their they hosted an AWS buckets in a row away. Like I don't get it. Like to me, I just don't get it. We still have people like that, but much less.
The rogue ones have to still convince them. There you go. Awesome. Thank you very much. Do you have any other things that you would like to say about Hugging Face before we close the episode?
They were Hugging Face.
I think something else to say about Hugging Face. But
you don't have more questions? I thought you had more questions.
No, we're good with Hugging Face. Like, what I did wanted to ask you, like, what is your favorite thing about working here?
People. 100% people. absolutely love people so much. I want to give a shout out to my team lead, Lissandre. He is the chief open source officer. Like, I don't know, like he has made me, like if you meet the right people, I think all of it has to do with luck. And, like you can just follow your guts. Like how I ended up here, actually, like I joined this company, when, like I had few options and then I did like a coin toss to, like see actually what I wanted. And then I chose this company and, I'm super grateful that, I met Julien, the CTO. There used to be, Omar, my former team lead. Yeah, like, it's all luck sometimes that you come across people in the right place in the right time and just follow your gut and it just works. I'd like to thank Lisandre actually. Like he made me such a confident person, as well as Pedro, my sort of mentor. Like both of them have quite changed me, I would say. So I would definitely say it's the people that matter in this place the most. You're also like a very nice person. Like I absolutely like to spend,
A little
but
bit.
it was super nice to chat with you.
Nice too. Absolutely, the feeling is completely shared. Well, there you go. Well, hopefully this way, we also give a chance to other people to get to know you and all the amazing people right here, and to contribute with the growth of open source and open models. Awesome. Thank you very much for joining me. It's been an absolute pleasure, and let's see. I'll see you next time.
See you.
Thank you very much. There we go.
Did you enjoy it? My brain